Hello and welcome back. In this lesson we're going to write our first simple program on the simple computer that we created in the last two lessons to evaluate this product, 35 times 47. Before we go into writing some code, let's just talk about why we can't make a simple program like this. So say we move the number 35 into slot 1, then we move the number 47 into slot 2, and then we just call our multiply instruction of slot 1 and slot 2 and store that, let's say, in slot 0. Why is this wrong? Well, let's go back to when we define the move instruction, and we see that here we have 2 bits for our instruction code, right? That's move. Then we have 4 bits for the value that we're moving in, right? So this value can go anywhere from 0000 to 1111. But what does that what does that mean? 1111 is equal to 15. Sorry, 1111 in base 2 is equal to 15 in base 10, which means that the maximum value that we can use in the move instruction is 15. So we can't do this. This is wrong. Number 35, which is 100011, is too big. It won't fit into the move instruction, so we're going to have to get a little bit more creative. And that's what we're going to do in this lesson. So ideally, we want to reduce this operation here to be a series of multiply and add instructions that use numbers less than or equal to 10. Now let's get started. First of all, let's just review the elementary school method that we're taught, to evaluate these long multiplications and why it works. Let's rewrite the number 35 as 30 plus 5, right? And you know that these two are equal. In the same way, we can rewrite the number 47 as 40 plus 7. Using this, we can say that 35 times 47, or 47 times 45, or times 35, is equal to 7 plus 40, right? I just changed the order, no big deal, multiplied by 5 plus 30. And again, all I did was change around some the order of some numbers, but these are still, the two sides are still equal, essentially, and that's what's important. So if we expand this multiplication out, we get that 47 times 35 is equal to 7 times 5 plus 7 times 30 plus 40 times 5 plus 40 times 30. And this is exactly what happens when you do the long multiplication that you're taught in elementary school. So let's just do this real quick, right? So we go 7 times 5, here it is, and we write that as 35, and then we say, okay, so 7 times 3 is 21, then we multiply it by 10, so it's 7 times 30, and then we're going to add it to the 35 we had before, which means that this evaluates to 245. And we do the same thing for 40 times 30. Now looking at this equation here, we've almost decomposed it into values that we can move into the slots of our processor, except for these here. So the 40, the 30, or sorry, it's just the 40 and the 30. And how do we solve this problem? Well, with a similar decomposition as this. We're just going to say, okay, so 30 is simply equal to 3 times 10, and 40 is equal to 4 times 10. And that's it. And now we can rewrite this whole equation with numbers, all of them being less than or equal to 10. See? All numbers are less than or equal to 10, which means we can now move them into our processor. Actually, the maximum value we'd be able to move in is 15, but we're just using 10 for simplicity. Okay. Now let's start writing some code. And this will be like this is pretty exciting because this is the first program that we're going to write in order to in the series of lessons in general. So I have this table here. This table is going to help keep track of our memory as we as we write our program or as we execute our program. So let's designate some slots for some sort of for some specific functions. So you know that in essence we're performing a whole bunch of additions, and in the end we want to converge to one sum for all of these things. So let's say that S0 is going to be where we store our result. This is where we do all the additions. Let's say that S1 and S2, these are the numbers that these are the slots we're going to use for our multiplies. And S3 is going to hold the number 10, because as you can see, we actually use the number 10 quite often. So let's just have that there all the time so we can use it in our multiply instructions. Let's start writing. What do we need to do first? Well, first, we need to initialize the value here. Right now, we need to have a sum in here of some sort of a result, and let's say that number at first will be 0, right? Because here you start from nothing and you say, okay, 0, what you're actually saying is 0 plus 7 times 5 plus whatever, so our result is also going to start with 0. And what's the instruction to move 0 into slot 0? Well, that's just move. So we're going to move 0 into slot 0. There we go. First instruction of our program is finished. Now, what we need to do next is we need to perform our first multiplication, which is 7 times 5. And as I said before, S1 and S2, these are going to be our multiplication slots. So what we want is we want to move 7 into S1 and move 5 into S2. So here we go, 7 and 5. Then what do we need? Well, we need to multiply them. Here it is. Here's that multiplication. And we use the multiply instruction that we've defined. So S1, multiply S1 by S2, and now we need to store it somewhere. Now, as you can see, our slots are all used up. So we're using S1 to hold 7, S2 to hold 5, S3 to hold 10. Oh, actually, I haven't actually even done that. So let me just fix my mistake really quick. Let's move. Oops. My eraser's not working. There we go. Let's move the number 10 into S3. There we go. So our slots are all taken, right? But we can carry out this multiplication of S1 and S2, and we can just store that result back in S2. So now, S1 still holds 7, but S2 is just going to hold 35, right? And then we need to add it to our current result. So add S0 and to S0, which is our result, we're going to add 35. And we're going to store that back in S0. So now the value in S0 is 35. Let's continue. What's our next step? Our next step is to do the 7 times 30 multiplication. Now, as I said before, we can't move 30 into S2, but we can do one of two things. We can move 3 into S2 and multiply it by 10, or we can subtract 5 from S2 because it already has 35 in it, but let's do this properly. So let's say, okay, so move 3 into S2, right? So now 3 is here. Then we can multiply S2 by S3, so that's 3 times 10. Whoa, oops. And we store that back in S2. So now the value in S2 is 30, the value in S1 is still 7. I'm going to start writing over here soon. And now we need to multiply these two numbers, right? So the 7 times 30 multiplication or the 7 times 3 times 10 multiplication is what we were going for. So we already have the 3 times 10. Now we need to multiply it by 7. So let's multiply the value, let's multiply the value in S1, which is 7, by the value in S2, which is 30, and store that back in S2, which is 210. And what we're going to do is just what we did before. Is we're going to add our multiplication result to our total result, which is in S0. So add S0 to S2, and we're going to store that back in S0. So now our value here is 245. Let's continue. The next thing the next part of this is multiplying by 40. So let's make sure that we have a 40 in our memory somewhere, and let's use S1. So the way we're going to get 40 is we're going to multiply 4 by 10. So let's move 4 into S1, and then let's multiply S1 by S3, which is still 10, and store that back in S1. So once this instruction finished, this was equal to 4, and then after this instruction finished, this is now equal to 40. And what do we multiply 40 by? Well, we need to multiply 40 by 5, and we need to multiply 40 by 30. So let's start with 5. First we need a 5 in our memory, so we're going to move 5 into S2. There it is. And then we're going to carry out the multiplication. We're going to multiply S1 by S2, and we're going to store that back in S2, and that's going to give us 200. And then, just like before, we're going to add our result to S0, store it in S0, and now we have 445. And we only have one more we only have one more term left, or one more expression to evaluate left, which is the 40 times 30. So let's move 30 into one of our slots again. So we're going to move 3 into S2, just like before. It's essentially the same thing we did. Here. We're going to move 3 into S2. Then we're going to multiply S2 by S3, which is 10, and store that back in S2. So now we have 30 in there. And then we're going to multiply 40 by 30. They're in our memory now, so it's all good. S1 times S2, 40 times 30, and we're going to store that back in S2. So 40 times 30 is 1200. And the last step that we need to do is now we just need to add whatever is in S2 to S0, store that back in S0, and now we have 1645. So this is our first little computer program. We had a very simple computer, and we used it to calculate something that it couldn't do by itself. And this is kind of what you're going to be doing as a programmer, is using the simple the simple constructs of a computer to perform much more complicated tasks than this. This is a bit of a contrived example, but hopefully if you stick around, we're going to get into more and more exciting things. That's it for this video. Thank you very much.